Okay, so
Yes,
sorry
you
about
can
that.
try.
So first of all, today I want to make a correction to last week's teaching. Division in standard form. There was a mistake in the explanation I gave. So we treated the example 9.06 times 10 raised to the power negative 9 divided by 5 times 10 raised to the power negative 6. I said there's a common term to this, to bringing out the common term, which is 10 raised to the power negative 6. When we bring out 10 raised to the power negative 3 divided by 5. Now, the mistake occurred here. There's supposed to be a division sign between this 10 raised to the power minus 6 and this bracket sign. Why is that? The reason why we need to put a division is because if we don't put division, that means we are multiplying it. And if we are multiplying it, that means we are working on multiplication instead of division. So putting a negative sign here tells us that we are minusing this power. So we have 10 raised to the power minus 6 into 9.06 times 10 raised to the power minus 3 divided by 5. So we have 10 raised to the power minus 6. This one gives us 0.00906 divided by 5. I think when we do this, we have, it should be 0.001812. So we have 10 raised to the power minus 6 divided by 0.001812, which is the same thing as 10 raised to the power minus 6 divided by 0.001812 is 1.812 times 10 raised to the power negative 3. So we have 10 raised to the power minus 6 because of this division sign. Now, this division sign, note that it only relates with the power 3. So this gives us 10 raised to the power minus 6 minus 3 times 1.812, which gives us 10 raised to the power minus 6 plus 3 times 1.812. And this is equal to 1.812 times 10 raised to the power minus 6 plus 3, that's minus 3. So this is the correct answer. Is anyone following? Hello? Hello?
Ma, yes, you are following.
Do you understand this?
No, I just joined just now.
Okay, so you don't understand.
Yes, ma.
I said the example we treated last week, there was a mistake relating to the division. 9.06 times 10 raised to the power minus 9 divided by 5 times 10 raised to the power minus 6. What we did was multiplication. Now, if we are bringing out the common factor, we should put this division sign here, so as to remember that we are not multiplying, we are not adding up the power. We are what? We are subtracting. We are not adding up. That's what this division sign is for. It is only relating to the power. It does not relate with the ordinary numbers. So we have 10 raised to the power minus 6 divided by 9.06 times 10 raised to the power minus 3 divided by 5. 9.06 times 10 raised to the power minus 3 is in ordinary form 0.00906 divided by 5. Then we have our 10 raised to the power minus 6 divided. So 10 raised to the power minus 6 divided by, when you divide this by 5, you will have 0.001812. Right? So we have 10 raised to the power minus 6 divided by 0.001812. 0.001812 in standard form is 1 point, because we are moving backward 3 times 1, 2, 3. So we have 1.812 times 10 raised to power minus 3. Don't forget that our 10 raised to power minus 6 is still there. Now, don't forget that this division sign only has to do with the power, not the ordinary number. So division sign in indices changes to, because of this division, which changes to minus. 10 raised to power minus 6 minus 3 times 1.812. So this gives us 10 raised to power minus 6 minus 3. Minus times minus is what?
Minus times minus is plus.
So we have 10 raised to power minus 6 plus 3 times 1.812 minus 6 plus 3 is what?
Minus 6 plus 3 is minus.
That's minus 3, negative 3. That's 3 minus 6. So that's minus 3. So we have 1.812 times 10 raised to power minus 3. Or another way we can go about this is when we have 9.06 times 10 raised to power negative 9 divided by 5 times 10 raised to power negative 6. Now, if we collect like terms, or we say 9.06 times 10 raised to power negative 9 divided by 5 times 10 raised to power negative 6. So this gives us 9.06 divided by 5 times 10 raised to power negative 9 over 10 raised to power negative 6. When we divide this 9.06 divided by 5, we have 1.812 times 10 raised to power minus 9. This division sign changes to minus according to indices rule. So
Yeah.
minus 6. So we have 1.812 times 10 raised to power minus 9 plus 6. So this gives us 1.812 times 10 raised to power 6 minus 9, negative 3. That's our answer. Do you understand?
Yes, ma'am.
Are you done writing?
No, almost.
Okay.
I'm done.
Okay. So I want to do correction for the last 2 assignments. Only one person submitted. Last 2 weeks. Last 2 week assignment, I call it assignment 1. So the first question was 3.5 times 10 raised to power minus 4 plus 5.2 times 10 raised to power minus 8. So solving this, we bring out the common term, which is 10 raised to power negative 4. When we bring out 10 raised to power negative 4 from both sides, we have 3.5 left in the first term, and then 5.2 times 10 raised to power negative 4 in the second term. So this gives us 10 raised to power negative 4 into 3.5 plus. When we write this out as ordinary number, we have 0.00052. So this gives us 10 raised to power negative 4 into, when we add up 3.5 plus 0.00052, we have 3.50052. And this gives us 3.50052 times 10 raised to power negative 4. Do you understand?
Yes, ma'am.
Seven times 10 raised to power minus 3 times 10 raised to power minus 2. So we have the common term here is 10 raised to power minus 2. I'll bring out 10 raised to power minus 2 from both sides. We have 7 minus 3 left. 7 and 3. So this gives us 10 raised to power minus 2 into 4. As 4 times 10 raised to power minus 2. Do you understand that? Do you understand?
Yes, ma'am.
The third question, we have 0.245. We're asked to write out in standard form. Can you tell me the answer to this? Write out that in standard form. Can you give me the answer? Hello?
Almost there.
Okay, there's one there. Yeah, can you give me the answer?
Okay, let me try.
Don't try, I'll give you
242 all over 100 raised to power minus 7.
You said what?
242 over.
That's write out in standard form. Did you get the question?
Yes, ma'am.
This is given in ordinary form, so we are asked to write out in standard form. Okay, so let me hear your answer. Hello?
I don't know.
I know you were saying something before.
Okay. Okay. 1245 all over 100 raised to power minus 7.
Okay, well, that's not the correct answer. Now, when you are asked to write out in standard form, the idea of standard form is writing out big or large numbers, just representing them in a smaller way. Instead of calling out this big number now, how can I easily call it out? That's what brought about the idea of times 10 raised to power whatever. Is it a big number, whether big, whether small? Just how can I call it out simply? So instead of saying 0.000 blah 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 blah, I can just easily say 5.2 times 10 raised to power whatever. So now, standard form is always in the form of b times 10 raised to power n. This base for the power is always base 10, and your power can be anything. Now, this b is always between the numbers of 1 and 10. Between of, let's say from sorry, between 0 and 10. So you can say 0 point, sorry, it's not even 0, it's 1. Okay, between 0 and 10, yeah. Between, so that's from 1 to 9. When they say between 0 and 10, this is from 1 to 9. So the idea is that the how should I put it now? Your B is always represented in a form that your decimal point comes after the first digit, not after 2 digits, not after 3 digits. If you have to represent something standard form, you cannot say 35.42 times 10 raised to power 7. This is wrong because your decimal point is coming after the second digit. Wrong. The idea of standard form is it comes after, your decimal point always comes after the first digit. Do you understand that?
No.
You don't understand?
Yes, ma'am.
Okay. I said this is the general way of writing. This is the general representation of standard form. B times 10 raised to power n. Our base is always 10. As long as it is standard form, it is base 10. Now your power can be positive or minus. And your power is also between what? Okay, it's a digit, it can be any digit, it can be raised to power minus 12, can be raised to power minus 100, raised to power 100. But this B is always between 0 and 10. Why do we say it is always between 0 and 10? Because it has to be the numbers between, it has to be a 1-digit number. A 1-digit number in the sense that if you say 7 times 10 raised to power 9, this is a standard form. Now, when you are saying 72 times 10 raised to power 9, this isn't standard form. As long as it is 2 whole numbers. Let me put it down. Is correct because your decimal point comes after the first digit. Do you get that? So in standard form,
Yes, ma'am.
your decimal point must always come after the first digit, not after 2 digits. You can't say 129.45 times 10 raised to power 3. This isn't standard form. It is wrong. As long as this number before the decimal point, or if there's no decimal point, as long as this number exceeds a digit. I hope you understand what a digit means. 1 digit. Digit, not number now. A digit. 0, 1, 2, 3, 4. Those are digits. So as long as this before the decimal point, or if it is an whole number, if it exceeds a digit, it isn't standard form. Now, if you have 129.45 times 10 raised to power 3, this is an ordinary number. It is written in ordinary form. If you are now asked to write in standard form, then you move your decimal point to the first digit. So it moves from here, 1, 2. So you have 1.2945. This one in itself give you times 10 raised to power 2 because you have moved this twice. So times 10 raised to power 2 times 10 raised to power 3. This 10 raised to power 2 plus 10 raised to power 3, you have 1.2945 times 10 raised to power 5. Do you understand? Do you understand?
Yes, ma'am.
So that's the idea of standard form. So standard form is always whatever times 10 raised to power times. There's no such thing as division. Don't forget, this is the general formula. So there's nothing like B over 10 raised to power n. No. if you have something in this case, your final answer, if you have to represent it in standard form, becomes b times 10 raised to power minus n. Since this is division, so when this power comes up, it becomes this. So you just have to find a way of representing it in this form. That's when we speak of standard form. No such thing as division. As I say, these are calculations in standard form. This is standard form. This is standard form. You calculate, and your final answer should be in what? In standard form. So that's the ideal thing. So we have to write 0.0000001245 in standard form. This what's it called? The decimal point is not after the first digit. Don't forget I will say B is numbers between 0 and 10. That is from 1 to 9. So if we want to write this out in standard form, we are moving this decimal point to here because this is the first digit. Do you get that?
Yes, ma'am.
Yeah. So we move from here 1. Your power, and we said our power tells us how many times we moved. So moving from here to here is 1, 2, 3, 4, 5, 6, 7, 8. So that means our answer is 1.245 times 10 raised to power minus 8 because you are moving forward. Do you understand? So it is 10 raised to power minus 8. The fourth question, which is writing 24,000 in standard form. Now, 24,000 is a whole number. So we don't see any decimal point here. So does it mean it is already in standard form? No. We still have 24,000 same thing as saying 24,000.000. You know that these zeros are insignificant. So just like there's an invisible decimal point here, we don't see. So now we move from this last digit, where 0 is ending, to the first digit, which is 2. So you have to put the decimal point here. You cannot put it here because if we put it here, this makes it 24 points. It is wrong. It isn't standard form. So move it behind 4. That is after 2. So we have 1, 2, 3, 4. So this gives us 2.4 times 10 raised to power 4. Do you understand? Do you understand?
Yes, ma'am.
Hello? Hello?
Hi.
Okay. Do you understand that?
Yes, ma'am. Yes, ma'am.
Can I continue?
Yes. Yes, ma'am.
Have you written this?
Yes, ma'am.
This is the first assignment. This is the second assignment. The second assignment, we have this question. Please excuse me. solving this question, we have 9 raised to the power 2x plus 1 is equal to 81 raised to the power of x minus 2 over 3 raised to the power x. So this is a question relating to exponential equations. I explained last week that when we want to solve a question like this, you have to break down your base to the base, equate your bases. That is, let your base be equal. Let them carry the same number, same value. So if you are working on base 3, let everything be base 3. If you are working on base 5, let everything be base 5. So we have 9 as our base here, we have 81 as our base here, we have 3 as our base here. When we look at these 3 bases, 3 can be common to them. Now, when you are working on indices, your brain must be working fast. You must be able to look at a number and tell what base and what power you can break it down to. So now looking at 9, 81, and 3. 3 is the base that is still common to these 3 terms. 9 is the same thing as 3 raised to power 2. 9 is the same thing as 3 raised to the power of 2. So we have 2x plus 1. Then 81 is the same thing as 3 raised to the power of 4 into x minus 2. Then we have our 3 raised to the power of x. When we multiply this, open this bracket, we have 3 raised to power 2 times 2x, 4x plus 2 times 1, 2, equal to 3 raised to power 4 times x, 4x minus 4 times 2, 8, over 3 raised to power x. So this gives us 3 raised to power 4x plus 2 is equal to, writing out this division, we have this 3 raised to power 4x minus 8 divided by 3 raised to the power of x. So we have 3 raised to power 4x plus 2 is equal to, applying the law of indices, we have 3 raised to power 4x minus 8 minus x. So this gives us 3 raised to the power 4x plus 2 is equal to 3 raised to the power 4x minus 8. This gives 3 raised to the power of 4x plus 2 plus 3 raised to the power of 3x minus 8. Is anyone following? Can you hear me? Hello?
Yes, we can hear you, and you have 9 minutes more.
Wow, okay. So, yeah, having equal bases, the bases are equal. So the ideal thing is you cancel this. I don't want to confuse us. Let me write it here. So you cancel this because you have equal base. Or you can say equating indices. So we have 4x plus 2 is equal to 3x minus 8. When you collect like terms, this gives you 4x minus 3x is equal to minus 8 minus 2. We have x is equal to minus 10. So that is the answer. The second question is 4.5 times 10 raised to the power 5 times 4.2 times 10 raised to the power minus 3 divided by 8 times 10 raised to the power negative 3. Now, we use the rule of odd mass here. So, solving this in orderly form, we solve this first, which is 4.5 times 10 raised to the power 5 times 4.2 times 10 raised to the power negative 3. So solving this, Let's solve this up. Let's solve this straight up. So we have 4.5 times 10 raised to the power 5 times 4.2 times 10 raised to the power minus 2. This gives us 4.5 times 4.2 times 10 raised to the power 5 times 10 raised to the power minus 3. When you multiply 4.5 and 4.2, you have 18.90 times, applying the law of indices to this, we have 10 raised to the power 5 plus minus 3. Plus times minus is what? Plus times minus is what? That's minus. So we have 10 raised to the power 5 minus 3, which gives us 18.90 times 10 raised to the power 2. Can I clean this place?
Yes.
Do you understand this so far?
Yes, ma'am.
Okay. So breaking 18.90 down, writing it in standard form, we have 1.890 times, let's cancel the 0, since significant. So 1.89 times 10 raised to the power. This 18.9 becomes 1.89. Move backward one step. Writing it out in standard form. So we have 1.89 times 10 raised to the power 1 times 10 raised to the power 2, which gives us 1.89 times 10 raised to the power 1 plus 2, which is 1.89 times 10 raised to the power 3. Now, don't forget to still add this to solve. So we have 1.89 times 10 raised to the power 3 divided by 8 times 10 raised to the power minus 4. Let's solve this. We have 1.89 times 10 raised to the power 3 divided by 8 times 10 raised to the power minus 4. This gives us 1.89 divided by 8 times 10 raised to the power 3 divided by 10 raised to the power minus 4. When we divide this, 1.89 divided by 8, we have 0.23625. Applying the law of indices to this is 10 raised to the power 3 divided by 10 raised to the power minus 4. It gives us 0.23625 times 10 raised to the power 3 minus 4. So we have 0.23625 times 10 raised to the power 7. This is 3 plus 4. So this is 0.23625 times 10 raised to the power 7. Now, can we leave this as our answer? No, because 0.23625 is not in standard form. So let's write this out in standard form. This gives us 2.3625. We move forward. 1 times 10 raised to the power minus 1 times 10 raised to the power 7. This gives 2.3625 times 10 raised to the power minus 1 plus 7. Can you see this? So this gives 2.3625 times 10 raised to the power minus 1 plus 7, 6. Let me write it out here. So this gives 2.3625 times 10 raised to the power 6. Do you understand? Hello?
Yes.
Okay. I think our time is gone. Oops. Sorry, I'm coming. So our time is gone. This will be all for today. Next week we'll start with logarithm. I would advise you come to the class with your 4-figure table. Does anyone have any question?
No.
No question. Good night.